Okay, so I think you guys can hear me perfectly, right? I think I'm perfectly audible. But anyways, just confirm me if I'm perfectly audible or not, okay? Otherwise, like I have to check the connection. So I'll just check it by myself only. But I think yeah. Okay, so I'm live right now. Sorry. Yeah. So just wait for a few seconds. So I'll just post it on Discord and just start with the video, okay? And just tell me one thing that if I'm perfectly audible or not, like everything is perfect or not, okay? Like the voice is okay or not? Because yesterday I think the voice was not that high, okay? So just tell me if it's okay or not. If it's not okay, then I'll just increase the voice a little bit, okay? So it's not a big issue though. So I put a little bit of gain, okay? So in case the voice is not that good, so I'll make it 4 decibel gain. I think that's perfect. Okay. Now I think it's perfect, right? Now I think everything will be crystal clear because I have put a gain on this filter. So guys, just quickly give you attendance that if you are watching this right now, okay? Meanwhile, I'll just post it on Discord. Bro, if I registered for the contest during the contest but not made any submissions, so will there be any rating impact? I know if I registered before the contest, it won't, but not sure of this. No, I don't think like there will be any like negative thing, but I'm not sure though. I'm not sure, so I have to check. And can you like young coder? Can you tell me like if I'm perfectly audible or not, and my voice is better than yesterday's or not? Because yesterday there was a little bit of like the voice was a little bit low, so I have put a gain filter. Okay. I'm perfectly audible, right? So let's do one thing. So let's just start with the video, okay, real quick. So we'll just start with the video. Anyways, how many questions did you guys do in today's contest? This is the first question, right? Yeah. Let's go with the first question. Okay. So the first question, you don't need to delete anything. Okay? It's okay. So the first question is you're given an array of integers nums of size 3. So you have to return the. Okay, just let me check if I'm audible. So you have to return the. I'm perfectly audible, right? Yeah, I'm perfectly audible. So let's get in the like question real quick. So return the maximum possible number whose binary representation can be formed by concatenating the binary representation of all elements in the nums in some order. Now, so for this 1, 2, 3, you know that the binary representation of 3 is 1, 1. Okay. For 2, it is, for 1, it is 1. Sorry, just this one. Just this one. And for 2, it is 1, 0, right? So basically, you have to concatenate them in some order so that the concatenated binary is like the maximum. And you have to give its decimal value to it. Okay. So what does it mean basically? Let me tell you. It was given in the question directly that the size of the numbers is the size of nums is basically 3 only, so you don't need to worry much about that. Okay, so let's say you have got three numbers. Okay, that is a, b, c. Now for every number what you can do is you can find out its binary representation. Okay, and after you found out its binary representation, so let's say this binary, so I'm going to find it out in the form of strings. Okay, So this is, let's say, string 1, this is string 2, okay, and this is string 3. So based on that, what we can do is we can like find out all the permutations of concatenating the strings. So what we can do is we can either have S1, S2, S3 as it is, or S1, S3, S2, okay, or we can even have S2, S1, S3, or 2, 3, 1, or 3, 1, 2, and 3, 2, 1. Because we know one thing, that the number of permutations for this is basically 3 factorial, and 3 factorial is 6, right? So 3 factorial is 6, that means there will be 6 possibilities, and over here you can see that there are only 6 possibilities. So we have found out all the possibilities. So we can concatenate them in all the orders and find out whichever is going to give us a maximum value for that. Okay. Anyways, people who are new to this channel, I'll just request you to subscribe my channel and like this video. Nothing more than that. So basically, we have to find which is the maximum thing. Okay. So now let's get into the code directly, because I don't think you need to understand this logic much. Okay. So I'll just directly go to the code. So this is a function bi which converts. It basically does nothing, but it converts binary to binary to integer. Okay, and the binary means binary string. Okay, because we are focusing on binary strings only. So now answer is equal to k. This is that. So you know what? How to convert a binary string to integer? We can go from the reverse and like make it plus equal to power of 2 comma k, right? Okay. Hmm. Why is there so less like people watching this? I don't know. Okay. So it's okay, it's okay. So you guys can watch it later also. So this is what we have done. We have just converted it, the binary string into the integer form, okay? And then we return the answer. And this is the main function, that is the maximum good number. So we have to like, I'm taking string 1 s1, string 2 s2, as I was mentioning in the Excalibur thing. Okay. And after I've taken all of them, so what I do is I'm going to go for like, I'm taking a is equal to nums of 0, b is equal to nums of 1, and c is equal to nums of 2, and then convert every number into its binary form. Okay, so that is this thing. Okay, this is what we are just converting it into its binary form for a, b, and c, and then we are going to check for all the possible combinations. That is s1, s2, s3, s1, s3, s2, s2. So all these possible combinations that I have told you guys. Okay, so I'll just use red for it. So all these possible combinations you have to check, and after you have checked it, so you have to return the maximum thing. Okay, so whatever is the maximum thing, you can just directly return it. Not a big issue, right? Not a big deal. And if you like compile it, so it works, right? Since okay, 3 people are watching it. So anyways, whoever is watching it, just tell me if I should go to uh, part B or not. I mean the second question or not. Okay. Just tell me quickly. Anyways, guys, I think you guys can't comment until and unless you guys have subscribed to me, because I have turned on the subscribers only mode, because like there are a lot of spam these days. So that's the reason. So just if you want to comment, just hit the subscribe button and then like write in the live chat. Okay. Otherwise, you can't write it. Okay. So let's move on to the next question. Remove methods from project. You're maintaining a project that has n methods numbered from 0 to n minus 1. You're also given two integers n and k. I mean, you're given two integers n and k, a two-day integer array invocations, where invocation of I is equal to a of I, b of I, which means that a of I invokes method b of I. So that is simply like you have to think it like it's a graph kind of thing. Okay, graph or tree kind of thing. It's basically a tree kind of thing only. Or no, it's not a tree kind of thing. It's basically a graph type of thing. Okay. So anything that like is connected from K is considered to be suspicious. Okay. It may be directly or indirectly. You don't need to focus on directly or indirectly. I am just telling you that anything like if you're starting from K and any of the paths, like from K, the paths that are coming out, if at any position you feel like that this element has come from K only, so you can directly say that it is suspicious. Okay. But you can remove the suspicion of that thing if some other group also invokes it. That is something invokes it which is not suspicious. So one is already suspicious, right? So let me just put it into Excalibur. Okay. I don't know how to select it actually. Yeah. Okay. So let's now look at it. Okay. So this is already suspicious. Now this is connected to this, right? So this is also suspicious. This is also suspicious. This is also suspicious. And is that connected to some other node? So it's not connected to some other node. So there is no other node that is suspicious. But one is have its source from 0 also, which is not suspicious. So we can remove the suspicion of this. And 2 is also connected to 3, which is not suspicious. So we can also remove the suspicion of this. So basically, how many nodes you have to remove? You have to remove all the suspicious nodes. Okay. So over here, all the nodes are right now not suspicious, right? All the nodes are not suspicious. So basically, it's going to be 0, 1, 2, 3, 4 only. So you don't need to remove anything. I mean 0, 1, 2, 3, not 2, 3, 4. There was 0, 1, 2, 3 only. But for this case, you can see that k is equal to 0 is suspicious. Okay. Now since 0 is suspicious, 0 is over here. So 1 is suspicious and 2 is suspicious. So 0, 1, 2. So all the elements in this are suspicious only. Okay. Even 0 is connected to 2 directly also. So basically all the elements 0, 1, 2 are suspicious. So you have like is can we remove its suspicion anyhow? We can't remove its suspicion because they are not connected to any non-suspicious element. That is 3 and 4. None of them are connected to 3 and 4 because they are completely different components, right? The component is completely different, so you don't need to worry much about it. So now what we can do is we are going to remove 0, 1 and 2. Okay, so basically the output is 3 and 4. And for this, again a similar kind of thing happens only. There's the fact that it is cyclic. So since k is equal to 2, this is suspicious. Now this is connected to 0, so that is also suspicious, and 0 is connected to 1, that is also suspicious. So all the elements are suspicious. So we have to remove all the elements. But there was one condition that you have to notice also, that is return an array containing all the remaining methods after removing all the suspicious methods. You may return the answer in any order. But this is the most important thing. Okay, if it is not possible to remove all the suspicious methods, none should be removed. So let me give you an example. What does they mean by this? Okay, so let's say you have got 0, um, 0, 1, 2 only. I think that will be more than enough for us. Actually, I have to check like what is the condition for which this should work. So let me just do one thing. I'll just purposely remove this condition where I was checking. I'll just purposely remove this condition and put it on submit, so you'll know that what is the exceptional case. Okay. Okay. So it was 1, 0, 2, 0 and 2. 1, 0, 2, 0 and 2. Okay. 1, 0, 2, 0 and 2. So 1 0 2 0, right? Now see, if 2 is the suspicious element, so 0 is also a suspicious element. Now 2, we can't remove suspicion from 2, but we can remove suspicion from 0. How? Because 1 is also connected, which is not suspicious. So this thing becomes removed, but this is not removed. Now since all of them can't be removed, so we have to keep all of them. Okay, so we can't remove the suspicious element. So the answer will be 0 1 2 only, rather than it being 0 1, because 2 is already suspicious, right, at this moment, so we have to remove it. But since 0 was also already suspicious, but it's now not suspicious, so we can't remove 2. I hope this is clear, right? This is clear. This is this part clear with you guys? Just write quickly in the live chat if this part is clear with you guys or not. Why the responses so less today? Did you give today's contest or not? Did you give today's contest? This is today's contest. I didn't get you. Today's what contest you're talking about? You're talking about today's what contest? Just tell me quickly. Yeah, that's only. Yeah, yeah, I've given it. I've given it. Otherwise, how can I explain it? I've given it. Okay, so now let's get into the code. Okay, different codes is your account, right? Yeah, exactly. This one. How to check it? Yeah, this one. This is my account. Now see, what you have to do is, okay. So what you can do is, since you know that initially only one node is suspicious, so you can perform a DFS or BFS. Okay. Over here I have written DFS, but I have done BFS. Okay. I have written DFS, but it won't be DFS, it will be BFS only. Because I have done BFS. I have written DFS just. So you have to just perform the BFS or DFS from that node. Okay. And for all the nodes that are visited from that specific node are suspicious initially. Okay. So let's look into the code rightly. So what I do is I'm taking the adjacency matrix, and I'm also taking the parent matrix. Okay, because I don't want the adjacency, since it is a directed graph. Okay, since you know that it's a directed graph, so you can't put the adjacency like the invocation of I of 0 is connected to invocation of I of 1, but the invocation of I of 1 is not connected to I of 0, because invocation of I of 1 has its parent as I of 0. Okay, so I'm taking two matrices, adjacent and parent. So I'm putting the values respectively in them. And then this is the answer basically that I'll be needing at the end. And then I'm vector for Boolean, I mean of type Boolean, so that I know that whatever like elements have been visited. So whatever element has been visited, it's more like it's not visited. Okay, it's basically like suspicious elements. Okay. Now I'm performing a DFS from K. Okay. And I'm just passing the visited and adjacency array to that thing. And you can see that if it's very simple. So if visited of K is, if we have already visited K, so we know that we have done all the DFS or BFS from that position, so we don't need to consider that. So we directly return nothing, like directly return it. And otherwise what we do is we are going to make I've got a sore throat actually. So what you have to do is where was I? Hmm. Okay, so if it is already visited, you can just directly return it. Otherwise, you can make that visit of k is equal to true. That is, I have visited it, and for all like I have to perform a BFS for it. That is all the adjacency nodes that are connected to it. So you perform the BFS. It's DFS. I have written DFS, but it's BFS. All I'm also telling you again. Okay, then you perform the BFS for that specific node and visit of that. Okay, so that's very simple. Okay, you can do it. And after we have done with it, after we have done the BFS traversal, then we are going to check L is equal to 0. Now you won't get it why I have made it L is equal to 0, but I'll explain you why we have made it. Okay, so for int I is equal to 0 to I less than n, if visited of I, if that is if I is visited already, so you can make int f is equal to 0. Okay, if I is visited. But if I is not visited, that means it is not suspicious. So if it's not directly suspicious, we can directly say that we can directly push it to the answer. Okay. But if it is suspicious, so we have to check we can if we can remove the suspicion of that or not. Okay. So okay, this was not needed. Okay, L is equal to 1. This is not needed. This is just an extra part. We don't need to focus on this for now. Okay. I don't know. I can't like delete it from the submission. But yeah, that was not needed. That was an extra thing. So what I do is I'm going to check like if any of its parent, okay, if any of its parent is not suspicious, then it is also not suspicious, right? Then f equal to 1. Now if f is equal to 0, it means that none of its parent are non-suspicious, that is all its parents are also suspicious and that element is also suspicious. So if such a condition appears, so we can directly say that that element, that specific element, it is going to be suspicious. So we don't add it. Okay. So that's the reason we just make continue. We won't add it. Okay. Now after that we are going to make L is equal to 0 and check like in the answer how many elements are still there which were initially suspicious. Okay. So which were initially suspicious, we have to check out how many elements are still there which were initially suspicious. Now if we find that it is not equal to 0, which means that not all the suspicious elements has been removed. Some elements are there which were suspicious, right? In that case, what we can say that we have to return all the answers, all the nodes. Okay, that is a of I is equal to I. Return a. And if it is not so, that means all the suspicious elements has been removed from the from our answer, so we can directly return answer. If it's like if all the suspicious elements haven't been removed, so that means that L is equal to L is not equal to 0. Okay. So is this part clear with you guys? If this part is clear with you guys, I'll move on to C. Okay. So if this part is clear with you guys, just write in the chat C. Okay. My 5 people are watching this. Please do subscribe my channel. Okay. Do subscribe my channel and like this video. Nothing much. So I'll move on to C. Okay, because I think that you guys have got it. Actually, I would have preferred moving on to D first because I think D is easier than C. But anyways, let's move on to C first. Okay, so let me tell you what this is. So I won't go into the I won't go directly into the question. So construct 2D grid matching graph layout. What does it mean? So it means that you're going to have a 2D graph, 2D grid, okay, and the points are like if there is a 0 over here, so you can see that 0 is connected to 1, okay, 0 is connected to 1 and 0 is connected to 2, okay, and this 1 is connected to 3 and 0, 2 is connected to 0 and 3. So basically all its adjacent elements are connected to it and you have to find a 2D grid of that. Okay, so it's not a big issue. Now the fact is that how you have to do it. Okay, that's a very interesting thing, how you have to do it. Like, is the question clear for you guys? If the question is clear, then only I move on to the explanation. Okay, I don't have the complete code because I think I submitted it from some other account. Let me do one thing. Let me just go into the editorial. Okay. Well, I think that this is a good question. Like that was a hard question for real. Python BFS, Java BFS, simple C++. I feel this is good. You can directly go to the code also, but the code is too big. So build an adjacency list and track the degree of each node. Exactly, group nodes by their degree for easier processing, right? Start from nodes of degree 1, then try pairing of degree 2 nodes and extend from degree 2 nodes until a valid layout is formed. Check if the constructed grid contains all nodes and matches the original edges or not. So see, one thing let me tell you guys, okay. Now since in a 2D grid, okay. So what can be the possible, like what to say, what can be the possible degrees of the things, okay. So let's say if there is a element in the middle, which means there will be an element above it, an element towards the left, not left, right of it, below it, and towards the left of it. So what is the degree of this element? It is 4, right? It is 4. Now you may have like elements which are having degree 1, degree 2, degree 3, right? But what I think is, I don't know, but what I think is like you can't have any element of degree 1, right? Because let's see what can be the possible values, right? So it may happen that we are having something at this corner. So in that case, this and this are connected to it. We can have something at this corner. So in that case, this and this are connected to it. Right? We can have something over here. In which case, this and this are connected to it. We can have something over here. In which case, this and this are connected to it. And we can also have something at this edges for which there will be 3 connected to it. Okay. So basically from this we can have an idea that for all the like for elements, what are the elements that will be in these positions, in the like at the end positions? It will be elements of degree 3 and 2. Okay. Now there will be 4 elements of degree 2. Okay, there will be 4 elements of degree 2 and some elements of degree 3 and some elements of degree 4. So how can we find out what are the elements of degree 2, degree 3 and degree 4? Right. So what my approach is, like I won't go into this approach actually. I'll just explain you my approach. Okay. But the thing is that I don't have the code because I couldn't code it during the whole like the time. But I think it works for it. Okay. So basically, what you can do is you can find out all the nodes which are having degree 2. Okay. So if after finding out all the nodes which are having degree 2, then we are going to find out all the nodes which are having degree 3. Okay. Now what we can do is there will be 4 nodes having degree 2. So we can place those 4 nodes at the corners. Okay. Now after placing those 4 nodes at the corners, so let me just use an example. It will be better for me. So I'll just use this example. Okay. Now you, so just look at it. Okay. So there are elements from 0 till 8. So 1, 2, 3, 4, 5. Now you know one thing, that this is the graph is not directed. Okay. So you don't need to focus on whether it's directed or not. 7 and 8. Okay. So for 0 the degrees are 1, 2, 3, 3. For 1 the degrees are 1, 2, right? The degrees are 2. For 2 the degrees are 1, 2, 3, 3 only. Okay. 3. For 3 the degrees are 1, 2. Right? It's 2. For 4, the degrees are 1, 2, 3, 4. And for 5, the degrees are 1, 2, it's 2. Okay. For 6, the degrees are 1, 2, 3. That is 3 only. And for 7, the degrees are 1, 2, 3. Okay. And for 8, the degrees are 1 and 2. I don't think there is any other degree. Okay. So 2. Now see, there are 4 2 degrees. 1, 2, 3, 4. Now these 4 elements are going to be at the corners. Okay. So no matter how you're going to arrange it, so it works. Okay. It works basically. So you can put them in the corners. Apart from the fact, there is one fact. So you basically need 2 combinations. Okay. Like for this you can either have. So I'll just make 2 grids. Okay. So it will be better for you to understand. Now this 1, 3, 5 and 8. So it can be like 1, 3, 5 and 8. Right. Or it can be like this. 5, 1, 3, 8. Right. Let's say 0 is connected to 1, 4 and 5. So 1 and 5, that means this will be a position of 0. Okay. And 2 is connected to 3, 4 and 5. That is 4, I don't know where it is, and 5. But see one thing, 3 and 5 is not connected over here. So we can directly say that this is a wrong thing. This is a wrong thing. So is it clear like how we are doing it? So it will be 0. Okay. And then we have to connect 2 for like, it was, sorry, I forgot. 2 was 3 and 4. 3, 4, 5. So basically this will be 2. And for 6 it will be connected to 3, 4 and 8. 3, 4 and 8. The 4 is not there, but 3 and 8 is there. So this will be what 6 will be connected to. And then 7 is basically connected to 4 and 8 and something else also. 1, 4 and 8. So basically 1, I don't know where 4, but 8. Okay. So that is what 7 is connected to. Now we are having 4. Okay. So now if you look at the solution, it was 863742105. 863742105. So it's basically a kind of rotation of the whole thing, but it doesn't matter because it was given in the question that you can either have the whole thing. Okay. Sorry. Okay. Return a 2D integer array satisfying the condition above. If there are multiple solutions, return any one of them. So we don't like need to focus on the like how it is. We can rotate it. Okay. So it doesn't matter. So basically this is very simple. Initially you're having 1, 5, 3, 8, and then you reverse this 1 and 5. Okay. And then go on checking, like go on putting it for this and this. Okay. Go on putting everything for this and this. And if you want to put it like that, what you can do is you can have 1 directly. Okay. And then you can start like traversing. Okay. So let's say from 1, if you go for DFS, okay, now we are going to focus on DFS, the fact of DFS, like how we are going to do it. So from 1 you can traverse to 0. From 0 you can traverse to 4. From 0 you can traverse to 5. But we won't traverse to 5. Actually we can also go for BFS also, it doesn't matter. So from 0 we can traverse to 5. And now we have got 4 and 5 in the stack, right? So from 4 we can traverse to 2. From 5 we can traverse to 2. Right? Now you can see one thing, that no matter what happens from 1, after like traversing for 2 positions, it is 2. Right? But before that, one thing that you have noticed, I think, it's not 2 actually, like it's lesser than that. So first of all, you have to find out what is the element that is in the corners that we have reached first. Okay, so you can see that before reaching these elements, we have reached from 0 to 4, and from 0 to 5 we have reached 5 directly, right? We have reached 5. Now since we have reached 5, so what was the like DFS between them? From 1 to 5, what is the DFS between 1 to 5? It is 0, right? So whatever is the DFS, I'm going to put that between 1 to 5. Is this part clear with you guys? Okay, not much people are watching this, so yeah. Okay, not much people are watching this, yeah. So I think this is clear with you guys, right? If it's not clear, then also I can't help. Okay, so basically using that, so basically this is kind of a DFS approach. First of all, you're going to fill up the corners and then go for the DFS, and whatever, like if you can traverse from 1 to 5, whatever is the DFS, just write it in the this thing, and then traverse from 1 to 3 and write it in the DFS, and then traverse from 3 to 8 and so on. Okay, just write them in the DFS, and then you will just find out one thing, that for one condition it won't be possible, and for the other condition it will be possible. Okay? That is as simple as that. So basically doing that, you can get it. And remember one thing, whenever you're traversing for DFS, you don't need to consider the elements which are having a degree of 3. So let me just summarize this whole thing. First thing, find degree to nodes. Okay, put it in corners. Put in corners. Okay, there are two possibilities. There are two possibilities only. So for all the possibilities, the third point, the third step, for all the possibilities, you have to check like DFS corner 1. Okay, so not corner 1. So DFS between all corners. Okay, DFS between all corners. And remember one thing, whenever you're going to perform the DFS, ignore okay, ignore elements of degree 4. Just a minute, okay? So what you can do is you can ignore the elements at degree 4 while you're performing the DFS. Then after you've done it, in the put it as borders. Okay, put it as borders. And while you are going to put it, so you can notice one thing, that any one of them cancels out of the two possibilities. So cancel out. So I'm just writing cancel out. You know what it is, what it means. Cancel out. So cancel out any one of them. Okay. And then it is very simple. Okay. Then it is very simple. Then you're going to mostly focus on the fact that what are the elements of having degree 4. Okay. Because now our focus is on degree 4. And for all the elements of degree 4, so what we can do is, now we are going to perform the DFS, but now the DFS is going to be DFS or BFS. BFS also works, okay. BFS on degree 4. Because we have encountered all the elements of degree 2, we've encountered all the elements of degree 3, now we are going to focus on degree 4. Okay. So is this whole thing clear, like how we are doing this? If this is clear, just write in the live chat so that we can move on to D. Okay, just write D. Because there are people watching this. I can see that there are people watching this right now. But they are very less responsive people. Can't help. Okay, so let's move on to the D. Okay, let's move on to D. Sorted GCD pair queries. This is somewhat, what to say, a good problem, okay, a good question. I'll go through the editorial also, but I'll explain you first my explanation. Okay, it may be that because whenever there is a hard question, what I feel is that there may be some other explanations which were much easier than that. Don't look at this. That is, there is a bug over here because yeah, I made a bug over here, but the approach is perfect. Okay, I'm perfectly sure about the approach. So the term GCD of A comma B denotes the greater. Okay, so for like nums, we can find out the GCD of all the pairs. Okay, for all the pairs in nums, and then we have to sort it out. And the queries in the queries, we have to find out from that sorted array of all the pairs GCDs what is the element at that position, at position of query of I. Okay, so basically, if you look at this 2, 3, and 4, so basically the thing is GCD pairs are GCD of 0 and 1, GCD of 0 and 2, and GCD of 1 and 2. So basically 2 and 3 is having a GCD of 1, 3 and 4 has a GCD of 1, and 2 and 4 has a GCD of 2. So if you sort it out, so 1, 1, 2, right? So it's 1, 1, 2. It's 1, 1, 2, right? And from here, what we can say one thing that after we have got that 1, 1, 2 thing, okay, we are going to find out which is at position 0, which is at position 2, and which is at position 2 again. Okay, so basically position 0 is 1 and position 2 is 2 and 2. So basically the output is 1, 2, 2. So this question, I think the question is perfectly clear for you guys. So let's do one thing. Let's move on to the explanation of this thing. Okay. Guys, just tell me if I'm perfectly audible or not. Like, I'm not sure why the watching is so low. I think it's okay, right? I think it's okay. So let's get into the question right here. Now, see, we can't compute for all the pairs, right? We can't compute for all the pairs. But what we can do is we can find out what is the frequency of the GCDs. Okay, so now let's look into this. Okay, what I can do is, let's say I have got two numbers, A and B. I want to find out what is the GCD of A and B, but I can't find out the GCD of A and B. Okay, you get it? So I can find out the factors of A. Okay, I can find out the factors of A, and then I'm going to find out the factors of B. Okay, so whichever is the greatest factor, that is going to be the GCD of A and B. So we are doing this without even finding like the normal orthodox method of GCD for all the pairs. But let's say we are also having C, and we have to find out the GCD of AB, AC, and BC. So in that case, if you're going to find the factors of C, so you can't have the following thing. Okay, you can't check for C and A and then C and B, right? That is going to give you a TLE. But what we can do is, let's say we are going to have a frequency of GCD array. Okay, now what it basically does is, let's say the factors of A was 1 and 2. What does it mean? That A was 2, right? The factors of B were 1 and 3. What does that mean? The factors of this was factor of. So what is the GCD of A and B? The GCD of A and B is 1. And let's say this is having 1, 2, 3, 6. That is 6. C was 6. Okay. Now for these two, if we are going to find out the common, it is 1. For these two, if we are going to find out the common, it is 3. And for these two, if we are going to find out the common, it is 2. Right? So the frequency of this one element with 1, this one element with 2, one element with 3. But how we are going to find it? Now let me erase the lines. Okay, now just look at it step by step. So after having this 1 and 2, we know that how many times there were 1 and how many times there were 2. Okay, over here there were one number of time 1 and one number of time 3. Now let's say what we are going to do is we are going to just reverse the position of A, B and C. Okay, so let's say we had A first, then C, then B. It is obviously possible, right? It's going to give me the same answer only, but it is going to make it more complex. Because if you're going to consider for 1, 2 and then go on till 1, 2, 3, 6, so it's going to be complex. So after doing 1, 2 and then when we are going to 1, 2, 3, 6, so we have to find out the GCD can be what? The GCD can be 6, GCD can be 3, 2 or 1. So we have to find out how many elements are there which are going to give me, which are going to pair with C to give me a GCD of 6. How many elements are there which are going to pair with C and give me an element of 3. Same thing for 2, same thing for 1. Now if you are going to find out for 6, there is nothing. For 3, there is nothing. But for 2, there is something, right? For 2, there is something. So how many factors are there? A number can have n factors, right? It can have n factors also. So it is going to give me a TLE back again. So what we do, we basically whenever we are focusing on the factor thing, we are just making it the square root, right? So how many factors are there? Basically square root of n into 2. These are the maximum number of factors that a number can have, right? So now the complexity is kind of reduced, right? From n till square root of n into 2, the complexity is reduced. In this, you also know one thing, that in this into 2, we can also remove this. Okay, so we can find out all the factors of n using square root of n. Now, after we have found out all the factors for square root of n, since we are not using this into 2, so we have an assurance that we are not going to get it in the specific pattern, specific order rather. Okay, so we can't have square root of n. You can find out the factors of that thing using square root of n, but whenever you're going to find the frequency of GCD, you can't have square root of n, right? So in that case, what you're going to do is, let's say you have got 6, so you're going to divide it by all the prime numbers. You get it? So you're going to divide it by 2. Let's say you're going to divide it by 2. So it becomes 3. Then you're going to divide it by 3. It becomes 1. Now you know one thing, that if 6 satisfies, I don't need to consider 2 and 3, because if the GCD of something is 6, the GCD is always divisible by 2 and 3 also. So 1, 2 and 3, all of them. But if it doesn't satisfy, then it can be either 3 or 2. And if even this 3 doesn't satisfy, then it will be either 3 or 1, right? So that is how you have to do it. Because we can't consider for all of them. We are going to find out GCD, that is the greatest of the factors. So let me just go with the code directly so that you have a basic idea. The code is not right, okay? The code is not right, and I think you guys will understand where the code is wrong. Okay. This is basically checking whether a number is prime or not. Okay, that is basic thing. And I'm having a frequency thing and a factorial thing. Okay, and I'm also having the prime numbers. Okay, so for int I is equal to 2, I less than equal to 5,000, 5, 1, 2, 3, 4. No, I think that was only 4 zeros were enough, because it was given that 5 into 10 to the power 4, right? So I'm just pushing back, like I'm just checking all the prime numbers in that range. Okay, because I'm going to divide, like, you know one thing, that when I was doing this, we are just dividing it with prime numbers. So we need to find all the prime numbers, right? Now n is equal to this. A is equal to nums of 0, factorial of 1 plus plus. If A is not equal to 1, factorial of A plus plus. Okay, that is, we are going to find, this is basically the factorial, okay, factorial of the first number. Because the first number, if there is only one number in the whole array which is not true because it is having two numbers at least. So if there is one number, so we can't have any pairs, but it is going to contribute to the factorial thing, right? So I'm just implementing the factorial thing. This is the square root thing, okay? And then for all the remaining elements from 1 to n, for which we can perform the pair, okay, I'm going to consider a is equal to nums of I, b is equal to a. I'm just storing in the a into b so that I don't override a, okay. And j is equal to 0. J is what? J is going to point the prime numbers, okay. The 0th prime number, the 1th prime number, the 2th prime number, or the 2nd prime number, something like that, okay. Now if factorial of b is already there, okay, that means if I am having an element and earlier there was an element which had that element as a factorial, what do I mean? Let's say I had 6, now I'm having 3, okay. Now 6 is going to have the factorial as 1, 2, 3 and 6, right? And this is not there, so this is going to be 0 only, so it doesn't affect the frequency of b, okay. Otherwise it affects it. Now while this happens, we are going to divide it with prime of j. Now one thing, that is, if um, b mod prime of j is equal to 0, I mean if it is not equal to 0, then we are going to make frequency of prime of j plus plus. I mean not plus plus, it's going to be plus is equal to factorial of prime of j, okay. And frequency of b is equal to that. So that is basically what we were doing in this thing, okay. Over here, this is all over here, okay. Now we are going to find the factorials, that is the same method that we used for the previous element, okay. And then we are going to find, like, we are going to have the frequency as a prefix frequency, okay. That is, we are going to find out the sum of frequency from 0 to n for all the elements, or from 0 to I for all the elements, because after that we can perform a binary search. Because if we know the frequency of, like, the GCD of this one happened 4 times, the GCD of 2 happened 2 times, so now if we want to find the 5th position, it's going to be 1 happened 4 times and 2 happened 2 times. That means 1 1 1 1 2 2, that is going to be 2. So using that we can find out, using the binary search, we can find out at which position it is going to happen, right? So now you guys can see one thing, that I'll just run it in front of you only. So for these 3 normal basic test cases it passes, but if we submit it, it is going to give us some error. But we were considering one for this. Why? Because one, okay, so let me just write it, okay. If result of, or like, what to say, like, right? Because this thing that we were doing, after 1 we can also go on till 1 1, right? We can go on till 1 1 because 1 is divisible by everything. 1 is divisible by everything, so we can just go on continuing till 1. So that is the case where this thing becomes recursively innumerous. But since you can see that 94 test cases are passing, so it is very evident that the solution that we have done, it works, okay. Just a few of the exceptional cases that we have to look into, nothing more than that. Rather, I think this will be better for you to understand, okay. If you compile this, then it will be better for you to understand what we have done wrong actually. It was 94 earlier, right? Now see, it's going to be lesser than 94, I think. It's 84, right? It's 84. What is the problem? The output is 0, but the expected is 1. The output can never be 0, right? Output can never be 0 because at least one element should be there. Like, we can't have a GCD of something as 0. But it is not completely false also, okay? Because 0 divides both of them. So basically we have to find a little bit advanced method. That's it. Okay. So what you can do is, if result of I is equal to 0, you can just go on to check it for like normally. Then result of I is equal to this. Else if result of I is equal to 1, result of I is equal to 2. Okay. Now this thing, it won't work either. It won't work either. Okay. Now see, the 23rd case only doesn't satisfy it. Why is it so? Because 2, 3, 4. Now this becomes 2. This should have been 1, but this becomes 2. Okay. So we have to like work on this. It's not a big issue, I think. You guys can work on that and get it. Okay. So I think that's from my side. Okay. So I'll just end the video real quick. So I'll just need a confirmation from you guys whether everything is clear or not. Okay, I think that everything is clear for you guys. So I'll just end the video. Okay. That's it from my side. Thank you. Radhe Radhe.